Hi, we are from At Home Tuition. In this video, we are going to see the naming of polygons and diagonals and also finding the number of diagonals of polygons with few examples. Next, we'll see the naming of polygons. So, naming of polygon is based on the number of angles the polygons have. Suppose if you take a three-sided figure, so it's a triangle. You know that already, right? So, it has three angles. So, you'll call it as triangle or trigon. So, if number of sides is 4 and it has 4 angles, so you'll call it as quadrilateral or tetragon. You know that examples: parallelogram, diamond, square, rectangle. So, all these are quadrilaterals. It's 4-sided figure and also it has 4 angles. Next, if it's a 5-sided figure, then it will have 5 angles. So, you call that figure as pentagon. The next, if it is a 6-sided figure, then it has 6 angles. Then you will call that figure as hexagon. Then if it is a 7-sided figure, it will have 7 angles. You will call that as septagon. Then if it's 8-sided figure, it will have 8 angles. You will call it as octagon. If it's 9-sided figure, then it has 9 angles. We will call it as nonagon or enagon. Then if it's 10-sided figure, you will call it as decagon and also it has 10 angles. If it is 11-sided figure, then it will have 11 angles and we will call it as hendecagon or undecagon. If it's a 12-sided figure, then we will call it as dodecagon, that it will have 12 angles. Similarly, 13-sided figure, it has 13 angles and we will call that as triskaidekagon. And if it is 14 angled figure, then we'll call it as tetrakidecagon. If it is 15 angled figure, then we'll call it as pentadecagon. 16 we'll call it as hexahidecagon. 17 heptadecagon. 18 octahidecagon. 19 enneadecagon. 20 icosagon. 30 triocontagon. 40 tetracontagon, 50 pentacontagon, 60 hexacontagon, 70 heptacontagon, 80 octacontagon, 90 enneacontagon, 100 hectacontagon. So, similarly for 1000 we'll have chiliagon, 10,000 myriagon. Okay. Then for 1 lakh we have megagon. Then 10 to the power 100 we'll have googlogon. Now we'll see how to name a polygon with in between numbers. Say example if it's 25 or 52 like that. So first we'll see for 20. So see 30. So we have seen previously. So this is for 20, 30, 40, 50, 60, 70, 80, 90 and 100. And we know that for 1 you have to add henagon, 2 diagon, 3 trigon, 4 tetragon, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 enagon. So now we'll see one example. Suppose if you want to name a 25-sided figure, you know that it will have 25 angles. So we can split this 25 as 20 plus 5. So to name 20, we know that it is icosi. Then 5, you know that it's pentagon. So 25 angled figure we can call it as icosi pentagon. Okay. Then if you take an example 78 angled figure, you know that we can split into 70 plus 8. 70 you can name it as heptaconta and then 8 it's octagon. So 78 is heptaconta plus octagon, heptaconta octagon. One more example we'll see for 99 angled figure. So 99 can be written as 90 plus 9. So 90 it is enneaconta and for 9 it is enneagon. So enneaconta plus enneagon you will get enneaconta enneagon. So 99 sided or 99 angled figure can be labeled like this. Next we'll see what's a diagonal. So a diagonal is a straight line connecting the opposite corners of a polygon through its vertex. Okay, it's also defined as a diagonal is a line segment connecting two non-adjacent vertices of a polygon. Two non-adjacent vertices of a polygon. Suppose if you consider this picture, it's a rectangle. So you are connecting the opposite corners. So opposite corners also called as vertex, and if the line connecting the opposite corners or the vertex, you will call it as diagonal. So for this four-sided figure, you have two diagonals. Now we have a formula to find the number of diagonals of a given polygon. So the formula is n into n minus 3 divided by 2. So this n indicates number of sides of the polygon. So we have a table for this. So now if it is a triangle, you know that it has 3 sides. So you can use this formula n into n minus 3 by 2. You will get number of diagonals is 0. Same way for four-sided figure, that is quadrilateral. The number of diagonals is 2. So similarly, you can find for any shape by applying it in the formula, you will get the number of diagonals. Now let's consider an example of octagon and let's find the number of diagonals of octagon. You know that octagon has 8 sides, so n equal to 8, and the formula is n into n minus 3 by 2. So 8 into 8 minus 3 divided by 2, 8 minus 3 is 5. So 8 into 5 divided by 2, that is 40 divided by 2, so you'll get 20. So octagon has 20 diagonals. Now let's see the number of diagonals with few examples. So the first question is, how many diagonals does each of the following have? So first is A, convex quadrilateral. So you know that convex means its angles is inside. Quadrilateral is a four-sided figure. So I'll give an example of convex quadrilateral. So now by using the formula, you can find the number of diagonals. You know that formula is n into n minus 3 divided by 2. Since it's a quadrilateral, the number of sides is 4. So by applying n equal to 4 in the equation, you'll get 4 into 4 minus 3 divided by 2. 4 minus 3 is 1. So 4 into 1 divided by 2. 4 into 1 is 4. 4 divided by 2 is 2. So a convex quadrilateral has 2 diagonals. Next question is, find the number of diagonals of a regular hexagon. So you know that regular hexagon means all the sides and angles are equal. So hexagon has 6 sides. So by applying it in the formula, n into n minus 3 by 2. Instead of n, we are applying 6. So 6 into 6 minus 3 divided by 2. 6 minus 3 is 3. So 6 into 3 divided by 2. 6 into 3 is 18 divided by 2. So it's 9. So a regular hexagon has 9 diagonals. Next question, find the number of diagonals in a triangle. So you know that triangle is a 3-sided figure. So n is 3. Now we are going to apply n is 3 in the formula. So the formula is n into n minus 3 divided by 2. So 3 into 3 minus 3 divided by 2. 3 minus 3 is 0. So 0 by 2 is 0. So we can say that a triangle has 0 diagonal. So you cannot draw a diagonal for the triangle. Hope you have understood all the questions well. Thank you for watching the video.